He's on.
Okay. Okay, it's 1:30. Let's get started. So as we've all seen again and again, this is our note well. Please note it well. Don't have anything funny to say about it, sorry. Do we have an agenda to project, or are we just going to dive right in? Okay.
Okay. Well, it was on right here.
All the tabs are lined up there.
Oh, I thought it was there. Nope. That was
Thanks.
fun. Not that one.
What are we looking for? Just
Look, the agenda I had it up on one of those. Not there. It was
well, you can just pull it up off this one. Scroll down to the here. I'll find it. I mean, if you want to start
yeah,
talking over it one side while I'm pulling this up, you can do that. There we go.
Okay, so I'm going to start because I'm going to, for my sins, I'm chairing the IPSec related work section. And so, John, I think we're going to go through agenda bashing, which is right now. Then we're going to go through my introduction to it, which will take about 15 minutes. In that, if you're an IDR person, I've put a whole lot of detail that gives you the TLVs, but I'm going to give the high level for the security people because TLVs may not be as important as the general security. Then Jun Hu is going to give a remote presentation on the IPSec single tunnel configuration. Then Linda's going to give some more details on SD-WAN ports because I think use cases are as important. And then Ali and Dave are going to give a presentation on the secure methodology for EVPN, at which point we're going to have a general discussion about the security methodology and issues relating to BGP VPNs versus other things. I know this has been talked about in sector and some things in, Sec Dispatch, not sector, Sec Dispatch earlier this week. So now you have to find my presentation.
Okay, hopefully we can.
It should be.
Is it this one right here?
Yep, that's me. Okay, this is an overview of IP links and VPNs for all of you who are IDR people. You know, I used to, when I had young kids, watch certain TV shows, and there was two levels of presentation. One was for the parents, and one was for the kids. And I liked it because there was that sort of fun. Well, you're all adults, but I put in enough details that if you're an IDR person, you can read the details, but I'll be talking at the higher level so we can interact with our security brethren. The drafts we're considering are draft Sagasi Best Secure EVPN, draft Hujun IDR BGP IPsec, and draft Dunbar IDR S1. There are supporting drafts. You have to realize there are supporting drafts for the secure VPN from draft Carol IPsec controller. There are some corollary work from I2NSF for an IPsec flow controller, and then there is supporting work in BGP from the tunnel, and a usage case from draft Dundar. So we'll just sort of reference these. I'm expecting you to read, if you're IDR, to know how to navigate a draft and find its supporting things, the rest of it. So why are this meeting? And you saw this in the BEST working group. We have multiple overlapping protocols on IPsec in BEST, IDR, and I2NSF. I2NSF is really looking at device controller, a security controller controlling many secure devices. So we got this, and our ADs said, you know, let's go work it out. So the BEST and IDR chairs agreed that common TLVs for IDR tunnel and cap should be agreed upon in IDR, which means we need to agree in IDR that that's the right place, because the tunnel and caps draft belongs to us, belongs to the IDR working group. The SA mechanisms need to be harmonized across the 3 drafts, but the IDR and BEST chairs admit full well we are not security experts. I know you may find that's unusual from the security that we admit our unknowingness, but we are. And then we have to determine in a subsequent thing whether the NRI requests in draft Dunbar IDR SDN port. So this is why you're here. We're trying to do the second. We're going to try to give you the various security mechanisms. We do not ask for an immediate answer. We ask for you to give us a sort of opinion. If you think this is a longer discussion with the security people, we should let us know, but we're trying to get a scoping. Okay, now this is mom and apple pie for all the IDR folks, but I thought I should throw in a few introductions. This is the basic topology. You have IPsec tunnels. Those are the things the data goes through. You have BGP peering. In some cases, the BGP peers talk directly to one another. And in many of the secure VPN and the SD-WAN case, they talk to a BGP route reflector. BGP route reflectors are our mechanism by which we scale. We scale tremendously. So I think I've gone through the fact that the Sagasi draft is a secure EVPN, that the Dunbar draft is the SD-WAN, and that Junhu's graph is trying to make provisioning and management of large numbers. Notice all of these say large numbers of BGP-based secure VPNs with large numbers of IPsec mesh tunnels. Who believes he can do it with simpler tunnels, and he can do it without a centralized controller? The question is, that's not a controller for BGP. What about a controller for the security control, as I2NSF has began to specify? One note I have to have is I am co-author on one of these drafts, but in this session, I won't be answering that draft. In order to keep it clean, I'm acting as a working group controller. So if you ask the question toward that draft, you have to ask my co-authors. Okay, so how do we look at this? We look at the use case, the architecture, the security issues, the hierarchy, and the BGP mechanisms. I need to give your security folks a heads up. We are replacing the BGP implementation for tunneling with the draft IDR tunnel attribute. It is essentially looking to replace the encapsulated extended communities, but BGP lives in an environment of deployment. We deploy things and we get implementations, and that's when we finalize the standardization. So a lot of these wonderful things that describe secure VPNs have already been deployed. So in that case, they may be going with the encapsulated and extended community, but in the future, we're hoping that people will transition to the draft IDR tunnel attribute. Why? Because there's some better security around the attribute. Okay, this is a general architecture that comes from the secure VPN, but seems to be followed. There's a zero-touch bring-up, there's a configuration management, there's an orchestration and signaling for BGP folks during the non-security association section. You can ask questions about that. There are 2 types of things. There is one administrative domain IP security function that Junhu is proposing. That's within a single administrative domain. That may have multiple ASs, but it is within one administrative domain, and that's a definition. The secure EVPN and the SD-WAN goes through multiple ASs and multiple domains. Okay, so there's a range of these security issues. So if you're reviewing one, you need to know what context you're in. Are you going across multiple administrative domains? And administrative means this guy owns it, he owns the security for all the boxes, and he owns all the BGP stuff. In the secure VPN and the SD-WAN case, they may be going between two places, perhaps two carriers, perhaps two cloud providers. The security issues that I, as a chair, and this is just my first stab in the dark, fall into two characteristics. You can have a controller to device. You can, and there are some assumptions here. We assume that the route reflector, which is the thing I'll show you that is like the controller, can securely identify the other node. We assume that is part of the operation in these architectures. We assume that they're setting up traffic selection policy. That's part of normal routing. We determine where you can send traffic, how we do it. A lot of the Yang policy distribution that's being worked on by the routing working group is doing some policy. Jeff, wave your hand. He's the routing working group person that's working on policy. That policy distribution has configuration in Yang and can be run over the Yang secure topology, just as if you had I2NSF. He's got the policy language Yang description. That's not the type of capabilities that might come from I2NSF. Now, if you set up the security databases, they could be downloaded outside. Yoon's draft does suggest that. But those are places you should look at us. You should say, do we know what we're doing there? Do you think we can have it? Conflict also could occur between two mechanisms. You could have two I2NSF mechanisms conflicting with itself, and there's a way to work on that. You could have two BGP mechanisms that are signaling these secure VPNs. You could have one of each. The goal in all of this is to have non-overlapping policy roles or rules. If you have it, in routing we call it preference. If I got top preference and we have a conflict, I win. So the routing people are used to that. And I think I went through the tunnel attribute, but in our attributes, we do have some policy that we've been working on. We have validation of origin ID because these are tracked by a route, and filtering, as I just described. Or if you want to get into the BGP SEC environment, you could signature various portions of the data. By what I'm meaning to the security people is this is the data portion of BGP. The links are secured via IPsec in most of these proposals, whatever they're distributing it. And but beyond that, we have data securing for the packets that go through BGP because the data is end-to-end and can be done. Okay, just for fun, IDR folks, I took a look at all the hierarchy, and there's hierarchy in most all of it, and I've laid it down there. That's my best reading of the drafts. Please tell me if you think they're wrong. For the security folks, notice we have significant hierarchy because we have to scale. In IPsec, we pass some data in BGP TLVs. We pass tunnel type, we pass port distinguisher, and some we pass nonce data, we pass rekey, we do a key exchange, and we have SA transforms. Those are actually being passed in the BGP PDUs that are being passed. Okay, we have some open issues for the working group to deal with. Because our IDR tunnel encaption is being obsoleted, some of these drafts are being revved. So if you have comments on some of this stuff, we could catch something in there. But our current tunnel types, based on the change of IDR tunnel encapsulation, some of them have to be read. For IDR, look at the number of drafts we have to now fix now that if we get tunnel encaption through. Okay. BGP secure requirements. Now this I'm going to stop and focus on. I put a little later in the slides because just before you see all the requirements, we have scalability issues. We have 10K nodes. We oftentimes in these things have 100 million links, 100,000 links. We have 10 million routes and maybe 20 million end customers. This is not the scale of even a small network. These are massive networks. Our robustness is 5 nines. In case you've never heard that term, it's 99.999% uptime. You have to have ready-to-go key management, SA on the fly within milliseconds. That may not be possible. That sure is the desire of the customer. Reoccurring occurs. This is not a static drop and go. This is a dynamic rekeying. There is a separate path for control and data that is hard baked into the scalability of BGP route reflectors, and there is network topology with non-directional links because of data throughput issues. This is a complex environment. I've just said a ton of stuff there. If you're a security person and you want to ask me what all this means, it's scaling with a star, and it means that some of your assumptions on IPsec VPNs has a different twist when we get to BGP VPNs. BGP is a control plane. This is, again, basics in respect for our security brethren who have kindly come. The compelling reasons for using BGP is widely deployed. It has a reliable transport. It has a guaranteed order. It could be run or mandated to be run over the best of TCP. We're not going to go into that. We're going to go into what happens after you have a secure link. The protocol runs on top of TCP. It has incremental updates that are, as I've mentioned several times, and I probably am repeating myself here, the routing reflector, which means routes go up to a central controller and then are distributed, reduces the full mesh, and the route table size. So we have to have that, and we have to have security built in. Route reflectors have the capability to apply policy to communication that's part of our DNA already. And that last phase, it's not 3 hours, it's 2 hours. BGP plus route reflectors support many types of topologies, hub, spoke, mesh. Anything else I've missed, our secure VPN folks will pick up for me. The implementations are robust, widely accepted. They go from data centers to corporate networks to mom and pop shops. It's flexible. Why are we asking you to help? You just probably got it. This is a longer conversation. Some things of what I was trying to get us to get to, you may have already, because the Carroll draft is specified it for secure VPN and SD-WAN leverages the Carroll draft. You may have an understanding of this in detail. They shortened it up, seeing that you'd seen it a few times. But these are the things I tried to look at what you were requiring. If you had something more and you want us to work toward it, please do. We're looking at generating IPsec SAs, rekeying, IPsec database generation, both SPD security policy and SAD. We're looking at peer authorization database and policy distribution. Kudos to June. He filled out all of his for the domain. There is the BGP security issues that when you have an implementation, you need to check the box whether you're doing origin filtering. That will require a link to the PKI or something nearby it. You need filters to string out attacks. Those have to be downloaded. That could be part of an I2NS download as one of the capabilities. And you have nested tunnels. Did I say nested tunnels? Okay, so with the hierarchy, you should realize that nested tunnels are part of our life. They are nested, sometimes 6 and 7 layers deep. I will take a quick check back and notice this hierarchy is about 7 layers. You can have people going that far in. Thank you. And I will be done. It is now June's turn.
So, I think we have a question.
Yes.
So, I looked at the meeting materials. Are the slides uploaded?
Yes.
Oh.
We're projecting them off the meeting materials.
It's in the materials.
They're in the Friday session.
June? Thank you, June.
Yeah, can you hear me?
Loud and clear.
Okay.
You can even back off a little.
Oh, yeah. Um, Thank you, guys. My session is really about the draft I wrote regarding to signal the IPsec config by BGP. So next slide, please. So basically, the draft defines a method using BGP to signal certain IPsec configuration, along with the NRI that the BGP updates. It relies on the BGP tunnel encapsulation draft for the IPsec configuration, and the BGP is only used to signal.
June, it's projecting really loud. Try to back off on your voice. We can't seem to figure out how to back off the meet echo.
Okay,
It's soft.
is it better?
That's better.
Okay, so BGP here in this draft is only used to signal the config part of the IPsec. The actual IPsec tunnel is still created by the IPv2 protocol between the routers that using BGP. So really, there's no change on how IPsec tunnel is created. This is still using IPv2, and everything regarding how IPsec works stays the same. There's no change on the IPsec part. The only thing I propose in the draft is on how to use BGP to signal the certain config of the IPsec. So here the list of the subtheories I propose that we could use to signal the IPsec config. First, we can use the existing tunnel type for the IPsec tunnel, which is type 4, ESP tunnel mode. I did not include the AH tunnel because it's hardly used in the deployments, and plus AH does not provide the confidential protections. So I only put ESP tunnel here in the draft. And also there are 3 new subtheories I propose underneath the tunnel encapsulation attribute. The first one is the public routing instance. So this subtheory is basically a routing target to indicate where the encapsulated IPsec packet will be forwarding. Because in the deployments, IPsec, the public side of IPsec is very different from the private side of the IPsec. This could be, for example, you could forward your IPsec packet in one of the VPNs. But
June, which slide are you on?
yeah, this is the slide. The
3?
the slide you're showing. Yeah.
Yep. Okay. We're fine.
Yeah. But your payload packet might come from a different total different routing instance. The second new theory, subtheory, is a remote address prefix subtheory, which is from the receiver point of view. So basically, this is the IPsec traffic selector, like DSI. And then there's another one for the local traffic selector, which is we call local address prefix. So both these 2 new subtheories basically contain one or more IP prefix that we use for the IPsec traffic selector. And then there are some existing subtheory I propose to reuse for the IPsec config. So one is a tunnel endpoint. So basically, this is now the IPsec tunnel endpoint address. And then there's a color. So color here in my draft is really aggregation for all other IPsec config that not specifically mentioned here, because I do not want to introduce too much change on the BGP side, and plus, in most cases, the transform, lifetime, they are all same on the all participating routers. They are all same config. So you typically have one set of those configuration, or you have a multiple set of those configuration. But typically, we have same configuration on every participating routers. So which means I can actually simplify this by just using a color to signify that that's the collection of those configurations. So there are two approaches here. One is to using existing color subtheories. Another approach is to just introduce a new color subtheory just for IPsec to avoid the confusion of using the existing subtheory. And then last part is the embedded label handling. So for the VPN routes, IPv4 or IPv6 VPN routes, which has embedded labels in the BGP update, which is used to identify on the data path which route instance or which VPN this data packet belongs to. But here for IPsec encapsulation, IPsec cannot really encapsulate a packet with labels. For IPsec, the only IP packet can be encapsulated inside IPsec tunnels. So here, I proposed we should ignore that label contained in the VPN routes, because with IPsec, the child SA could already identify which route instance that packets belongs to. So you don't really need that additional label and update. So I propose to use that value 2 of the embedded label handling subtheory to signal such process. So next slide. So here's a table I created to mapping between the needed IPsec config to the BGP signal config. So for the IKE, for all the IKE config, like the IKE SA transform, IKE authentication method, credentials, lifetimes, etc., like the and DPD, those are all aggregated by the color subtheory, or if we decide to use a new subtheory for this purpose. For child SA mode, like for example ESP tunnel, it's a tunnel type field in the tunnel encapsulate attribute. For the child SA transform, that's also aggregated by the color. And for the traffic selector, local or remote, and I think there's a typo there. It should be one local and one remote traffic selector address range, which is signaled by both those new subtheories mentioned in the previous slide. For the traffic selector protocol and port range, it's not signaled. It's assumed as any. So which means the only traffic selector field we signal via BGP is the address range or prefix. For the anti-replay config, it's aggregated by the color. ESN config is also aggregated by the color. Next slide. So here the table showed in the previous slides that I filled out. So the generation of the initial IPsec essays is based on the routing lookup. So based on the when a router needs to forward a packet, he will do a routing lookup. And if he decides using a particular BGP update, and that update has a IPsec tunnel encapsulation attribute, then he will use that configuration to create an IPsec tunnel via v2. And that tunnel creation will create the initial IKSA and child SA. And for the rekeys, both IKSA and child SA rekey were down via v2 based on the config that we using in the tunnel creation time, signaled by the color subtheory. So basically, typically you will use lifetime-based rekey mechanism. So that lifetime you signal by the color. Also, there's not much difference between single device rekey and a multiple device rekey, because all the rekeys here is that down via standard IPv2 operations. The device rekey with its tunnel peers, there's no involvement of any third-party device. The rekey happens between these two tunnel peers. For the different IPsec database, for SPD is essentially signaled by the NRI, which is the routes, local prefix and remote prefix subtheories. For SAD essentially is the child SAs. The child SA is created dynamically when the IPv2 creates a tunnel or when the child SA rekey happens. And whenever a new child SA or child SA rekey happens, the new set of keys known as SPI are generated dynamically. For the peering database, PAD, this is a signal by the tunnel endpoint subtheory. For the policy distribution, the advertising routes signal these IPsec config. It requires other to use when reaching the NRA it advises. So basically, a router advises certain routes, and along with those routes, it also advises what kind of IPsec tunnel you need to use in order to reach this route. This could be done with RR or without RR because this is just standard BGP updates. The receiver use normal BGP routing lookup mechanism to decide which update to use. So in case, let's say, if there are multiple routes, multiple router that applies same routes, but with different IPsec config, then receiver just using standard BGP mechanism, like for example, based on the preference to select one BGP update to use and use the corresponding IPsec config in that update. So next slide. For the security issues related to this approach, so all the standard BGP security mechanism could be used to enhance the security of the BGP updates, like origin verification, filter, BGP stack. For the nested tunnels, just like other type tunnels that you signal via BGP, you have to pay attention to avoid looping because in case there are multiple nested tunnels and there will be multiple BGP updates, you have to be careful not to make a loop out of it. So basically, you have to either intentionally or unintentionally misconfigurations that might cause the loop. Next slide. So my draft is really focused on the single administrative domain. But if you want to have it work across administrative domain, the only thing you need to make sure is that the mapping between the color and the IPsec configuration are agreed. And also, I didn't put it here, but it's also important to have a common set of authentication framework and credentials policies. For example, let's say if you're using certificate authentication, you make sure these two organizations trust each other's CAs and its CAs issued certificates. As long as you can do those things, I mean, this draft could also work across administrative domain. But typically, you want to use the draft within the same administrative domain. So the distribution of a traffic selection policy is by the advertising router, because again, the main use case of this draft is that if you don't have any central controller, and this is just like a normal routing, like traditional routing, how routing works. Each router makes their own decisions and also make their own decision of what kind of protection they want to have for these routes they advise. So the advertising router will decide what kind of traffic selection policy they would use, and the receiver of those BGP routes have to use those IPsec config that including the BGP updates to reach those prefix, those routes, because the receiver will enforce, the advising router will enforce the check of the receiving traffic, that if the receiving traffic comply with the IPsec config that it advised in the BGP routes. For the controller conflicts, so again, if two routes advise same NRA but with different config, it got resolved by the normal BGP mechanisms. For BGP, non-BGP, so if there's such confliction between this draft and another mechanism, for example, a local provision or provision for a controller, I mean, this is really local matters. It's up to the implementation to decide which one to prefer, but typically we would say, for example, if you have a local configured IPsec config that overlaps with the BGP signaled IPsec config, typically you would want to favor the local config ones. And then for the last part, the zero touch setup. So this draft does not actually address the zero touch provision because it requires some pre-provisions before this can work. For example, you need to pre-provision the color to IPsec config mappings, and also you need to pre-provision the IPsec authentication mechanism and its credentials. But it could be facilitate the zero touch provision. The only because we only require the relative static config because the authentication credential and color mapping it's typically is common for all the routers, and typically it won't change very frequently. So you could actually pre-provision those via other means on the routers, but have this dynamic part like the traffic selectors and those things signaled by the BGP.
Thank you, Hoon, for all those good pieces of information, folks. For the security folks, we'll give you a bit of a moment to investigate that. Unless you have a burning question, we'll take all questions at the end.
Clarifying questions, I think.
Clarifying questions.
Yeah, if you have clarifying questions related to this draft, then now is a good time. Otherwise, we'll, as Sue said, take questions at the end. No one approaching the mic, so thanks, and we'll go on to, who's our next one? Is it Linda? Okay. What the heck happened?
Just give me a second.
Oh, there.
Can you hear me? Okay, that's good. Thank you. So here I'm only going to talk about user scenarios, key requirements, and I know we have some offline discussion on how do we encode the bits and information. I'll leave that later on. We'll talk about later after Ellie's draft. So how do I adjust it? Okay, so the key things about SD-WAN, I present this in the RTG working group briefly on the problem statement. You're talking about multi-players. And, you have service providers, have the VPNs, you have the ISPs for the internet connections, and you have cloud provider offer connection from their gateway, respective gateway, to your virtual router, and you have your CPE device somewhere, maybe on your campus, or maybe in a shopping mall, or maybe in some remote office. So the SD-WAN itself is about the overlay. As you can see here, like for example, the MPLS network itself has their own BGP control. That's the one BGP version. You can think about underlay BGP layer. And this dotted purple line here is control the devices in very different geographic locations. You could have one CPE located here in Montreal, and you could have your virtual CPE located in some cloud data center in a different country. And you could have a controller using some kind of TLS or some kind of DTLS to be able to connect to those two devices and then distribute information, distribute IPsec configuration or IPsec key establishment. So here in this example, I only show just one cloud location, one CPE. But in reality, as Sue mentioned in the earlier slides, there could be many, more than hundreds, more than thousands. And in the past, in our deployment, we use an HRP to kind of resolve some of the addresses and tunnels. But once the network go beyond 100, it just doesn't scale anymore. So we retreat to BGP because BGP has been proven can scale to much larger number of nodes and sessions. So that's some key characteristics of this SD-WAN. Here we call hybrid SD-WAN simply because for this virtual router, they can have different ways to be connected. One is through secure network. See, if the traffic goes through MPLS network and through the direct connect to the virtual router, the traffic don't have to be encrypted. If packet goes that way, then they can go natively to have better performance. And if traffic have to go through the internet, then that has to be encrypted. So IPsec only apply to certain traffic going through certain path. And same traffic, maybe in the morning, it goes through the private network, through the direct connect to the virtual router that doesn't have to be encrypted. And then maybe later on, when the traffic condition in the private network get congested, maybe shifted to the public network through IPsec, then that has to go through the encryption. So the policy on where to send is a local decision from like CPE1. They have basically have different kind of monitoring system, which is beyond the scope of IDR, to monitor the network condition, monitor the application status, and then make local decision on where to send. And for many cloud today's application, there'll be many components, right? So application components can be instantiated at different locations, and same application, they may have multiple versions of it, multiple instantiation of it, and based on some policy, sometimes can be regulatory requirement, sometimes can be performance issues, and the connection can be site-based. Like say, for example, my traffic has go through certain sites because of I have to comply to some regulatory requirement. So, and for the SD-WAN, like the virtual path, the BGP connection, have to take the site into consideration on top of your node ID, on top of your port ID. So there's another layer, site. That's just another requirement that has to be considered for multi-cloud interconnections. And for example, in this example here, I only show that from CPE to cloud data center 1 and then cloud data center 2, the traffic between the two cloud data center, like virtual router in data center 1 and the virtual cloud in data center 2, sometimes need to be communicated, and there will be paths among them as well. And the paths among them can be encrypted through the public network, or can be through the trusted network. So just in general, this one has been presented in the RTG working group. It's about, here just summarize two different type of SD-WAN scenarios. One is I call homogeneous SD-WAN, meaning that all traffic are encrypted. You have a CPE like in a shopping mall. All the traffic from this particular device to my campus network or to my other places are encrypted. And so it doesn't matter which WAN port you egress from. Another one, we call it hybrid network. Hybrid SD-WAN, meaning that some WAN ports need to be encrypted. Some WAN ports you don't. So it's really from WAN port, the WAN perspective. From the client side, you have client attachment, which can go through either port. So the for the SD-WAN control plane, the peer-to-peer model doesn't work very well, simply because I have those kind of virtual edges. They actually can be instantiated in different places, and they overpass multiple domains. And so we need the dotted line raw reflector, which runs at the different layers from the underlay network to connect them together. And it's very important that those devices, when powered up, be able to have a burned address they can reach to and establish secure channel. This is not just for IPsec attributes only. This is for other purposes like policies, who you can talk to. For example, this R1 being instantiated. He wants to communicate with certain applications. He doesn't even know where the application is located because they may all have their own private addresses. So the sequence is R1 has to send those traffic requests to the controller, which is I call it raw reflector simply because when BGP is used, BGP itself has the mechanism to distribute control information. And so all the communication is not directly through each other, it's through peers, and it's really through the controller. I know that in the security dispatch discussion, there are people debating on whether we should use controller or should be peer-to-peer. So just for your information, the controller is there, even if it's not for IPsec purpose or IPsec key distribution management, it is there for other purposes. And also for the route distribution, just like EVPN, you may have attached routes. You need to propagate that route to other peers, which in your domain. And that's also through the raw reflector because the edge node don't know how to reach to the other peers. And it's important that for the edge node to register his WAN ports, right? My WAN port today, I have 3 WAN ports, and one is connect to direct connect, is a VLAN or is a secure connection. Another one is private address, which need NAT. Another one maybe is public address, public IP reachable, but you can use that to establish the IPsec tunnel. So, and then on top of that, for the ports which need encryption, they need IPsec management. So, so for the WAN port propagation, as I mentioned earlier, is through controller. And see, for example, here I have CPE1 in Dallas, I have a CPE2 in Beijing. CPE1 need to communicate with their corresponding application, and they need to go to the controller to figure out where is the CPE2 and what is the public address for CPE2, because they are all they may have private addresses, and then through that they can communicate, be able to establish channel. You have questions?
I have questions, but I can wait till you're done. Or
Okay.
That should be the end of the. I think that's the end of the. That's the last slide. Okay, so in terms of how do we encode the information, we have lots of discussion with Ali, and we all agreed that using tunnel encap is the right way to move forward. And later on, I have a couple of slides showing different ways of doing it, the pros and cons of different ways. So we can defer that discussion to later time. So today, because lots of people from security are here, our main purpose is to maybe convince you guys that for the IPsec configuration, it should be controller facilitated. Peer-to-peer doesn't scale well. Okay. Did you have a clarifying question?
Yeah, indeed. Kev Patel Arcus. Maybe you can expand a little bit on a need to signal WAN ports across a provider networks. I mean, you brought out a brilliant case here where that you may want to shunt traffic over different ports at certain time of the day. Are you expecting to add that when you signal that, of course, through the WAN ports to increase the chatter within BGP?
Okay.
Maybe some.
Okay,
Would be
so
interested in your thoughts.
okay, so the WAN port itself actually is not really when you need to send traffic. It's really when the node gets powered up. Because for the SD-WAN, one of the important requirement is zero-touch provisioning. You put a box, you ship a box to your client, to your customer. They power it on. Supposedly, zero-touch provisioning will require that box to be able to be up functioning. So depending on this WAN box, where they are located, say if they are behind a net, right? So they need to send a signal to the controller, route reflector. Here's my box. Here's my port. I have 3 ports functioning, and the port 1 is a private address, but my net property is this. I can go using some kind of mechanism. I have details in the draft showing that I have mechanism to detect my net property. So I tell the controller. So in this example,
just a minute, Linda. Care, I want to make sure that I heard the question slightly separately. Did you get the answer to what you have? I think we'll have to delay the detailed scenarios offline, but did you get the answer?
No, I didn't. It would be good if you can send out an email on a mailing list explaining it. That would be probably better in the interest of time.
Your question?
My question is the need to signal. And if you're going to signal it, because the other end really doesn't care, it works on the routing. So what's the need to signal? And if you're going to signal, are you going to add, what's the implication on the chatter of the update message?
So the challenge on the rekeying or the challenge or just to do it at all? Okay. We've got the question. We'll pick that up later. Thank you, Linda, for the good presentation.
Thank you. Thank you very much.
You can just give it to Dave and Ali. They're going to. The listing in the agenda is Ali, but Ali and Dave are going to tag team. Maybe it'll be more entertaining that way.
I'll dance. So let me just take it off. Easier. So we got the shortest presentation, but it takes 2 of us to present. I'm not going to be presenting what is on the agenda, which is secure EVPN, because secure EVPN is a solution, and it is talks about how we doing the point-to-multipoint signaling over BGP to set up the point-to-point IPsec assays, and it talks about the details. So before getting into the how we do it, we need to talk about what we are doing it and why we are doing it. And given that this is
the mic picking Ali up for everybody. Can you hear him all right? Okay, thank you.
Okay, go ahead.
And this is given that this is a joint session between the security and BGP team. I like to keep it at the high level, making sure everybody is on board with the what and why, and then later we get into the how. If I start with the architecture component, which is not also in this slide, it basically we are talking about the 3-4 main components. One is zero-touch provisioning, such that when you have an edge device, you can just turn the power on and goes to his ZTP server, gets the info where to get the configuration. And then the next component is the configuration component, that edge device gets the configuration component from it over the secure channel. And then third is the signaling component that deals with signaling the information we need to set up the IPsec assay, as well as to do the keying, rekeying, and so forth. And these are the 3 main components. And with the provisioning, we defer that to I2 and SF. With the ZTP, it is outside of the scope. And so the signaling is what we're going to emphasize in here. And we're going to talk about why we want to use BGP to set up these IPsec assays. So a little bit of the background that I started the EVPN about 13, 14 years ago, and that got started as a research project. And right now, it is very prevalent in data center, in SP, and in enterprise. It's basically de facto overlay controls protocol and solution. It has many reasons. One of the reasons is BGP. Okay. With respect to the capability it has, with respect to its proven scale, proven functionality, flexibility, all that goodies. Okay. So that with the same principle, we want to leverage that for the security aspects when we want to add the security feature and secure the tunnels. We currently use one signaling mechanism, and that's BGP. And there has been precedents before that in the last 15, 20 years for the people who've been around, okay, a solution had two signaling mechanisms, such as for the multicast VPN. We did both BGP and we did PIM, and we converged to BGP for the L2 VPN. We did targeted LDP and BGP for discovery. Then we converged to the BGP and many other instances. This one, we have a BGP. We use the BGP to set up many tunnels. And for the IPsec tunnel is only one tunnel among many that we set up, and we want to leverage the same signaling in here. And some of the customers basically they're not only asking using just the protocol, the signaling protocol to be BGP, but also even to use a single AFI, SAFI, or for example, a single solution within that. That is basically the motivation to use BGP in here. Next, please.
You've got it.
There we go.
Okay.
Take team. Yay.
Sure. So I came at this from the SD-WAN side of our house. We developed SD-WANs not using BGP, but with a really similar architecture. We've got a management station that would be very analogous to what an I2NSF does. We've got our orchestrators that work very much like a route reflector does. And we send around our keying updates and our routing updates for the overlay network all together. It is entirely, analogous to what we're proposing here with the route reflectors. So we have a key exchange protocol for those who weren't in SecDispatch or IPsec-ME a year or so ago. There is a draft on our key exchange protocol that we've put out. The rationale for this is keeping it controller-based. We did this because of scalability, as Ali was talking about. That's kind of the primary functionality for it. Everybody talks to a central controller. Those are replicated. They communicate with each other. They push the information down, and we got the scale that we needed. There are other needs that this met. We don't want to drop packets. Obviously, when something comes through and you need a session established, we don't want to spend the time to do 6 round trips or 3 round trips or whatever we're going to do. We want those packets to just go out. So we have sessions usually pre-established. If they're not, it's very quick to establish them. Because we don't have to actually go off box to get the information. We found other issues that made the controller-based model really nice for us. We run control connections over typically provisioned, quote-unquote, secure networks. Certain of our customers insist upon this. Data may go out over the public internet or a public network, but control goes over the provisioned networks. And so I'll go really high level into this key exchange thing. I don't want to go into a lot of the details of it here because I think that's a task for later if we decide to move forward with any of this. But the concept is actually really pretty simple. We send, it's a Diffie-Hellman exchange, but it's done through a centralized controller. So an individual node will create a Diffie-Hellman pair, send the public value up to the controller. Controller aggregates all the public values from the different nodes, and it sends out updates on a regular basis. Now, everybody knows everybody else's public number. You can create a Diffie-Hellman pair. You know, there's a little bit more to it. There are nonces, and we try to do some good hygiene and some other stuff. But at a high level, it's just a simple Diffie-Hellman. Some key misconceptions. People have thought this was long-term static Diffie-Hellman. It is not. We rekey in the lab when we're trying to thrash on this stuff. We rekey every 15 minutes. Typically, that's not how often you're going to rekey in the real world. But it does thrash the stuff, let me tell you. But things do rekey, and honestly, the part of this protocol that makes it more interesting than just, hey, we're exchanging Diffie-Hellman pairs, is the synchronization over the rekey. So if you imagine a network with 10,000 nodes, you need to keep that all synchronized when one of them decides to rekey. He's going to send information to a controller. It's going to get to the different nodes at different times, and yet we can't drop packets. It's pretty complicated if you think about that one node rekeying. When you think about all 10,000 nodes randomly rekeying at their, at their offset of the key interval, it gets pretty hairy. If you read the draft, it goes into a lot of detail. I'll have a slide in a moment. It talks about how that's synchronized. Go. Oops.
It can go back the other way.
I do. I need to go back.
There you go.
Resynchronization. As stated, the route reflector, or in our case, in SD-WAN, it's not a route reflector, but it's the same device. It optimizes that distribution. It waits for keys to come in, knows when to send them out. I refer to this mechanism as kind of a lazy synchronization. Lazy sounds like a negative term, but the key point of it is there are no hard timing considerations. I don't have to get that key to another peer at a specific time because I know I'm not going to. And the protocol is robust for letting them trickle in on different schedules to different peers. I think you get the next one.
Okay, I'll go over the example. So before going over the example, let me put the example in perspective. Imagine a route reflector, and we have a bunch of edge devices, and the edge devices are connected to the route reflector via, they have BGP session. Each edge device has a BGP session to the route reflector that goes over a secure channel. Now, this secure channel can be TLS, can be IPsec itself, or whatever. So the assumption is BGP signaling goes over secure channel, and then we use the BGP to set up these IP SA. So in here, I gave an example a little bit. I wanted to just, for the illustration, that although I came up with 10K peers, okay, that can be 100 peers, and each peer can have 100 tenants, and you're trying to set up the IPsec on a tenant basis. So you end up with, again, the full mesh of 10,000. So let me cover 2 more slides, and then we are open to and one more after this. So the reason I put these number there a little bit, to provoke your thoughts, and also to make the differentiation a little bit, clear. So if we talk about the, let's say, 10K peers, and as I said, these 10K peers can be just not the, another example would be 100 with 100 edge devices with each with 100 tenant in it. And we want to set up IPsec tunnels among them, basically 6 IPsec messages, IK messages per session, and we got 10,000 square, which is 600 million. With route reflector, basically every peer sends one message to the route reflector, and the route reflector aggregates them, and it sends it we can do it on an interval basis to send it to push it to everybody else. So depending on where you set the interval, the aggregation interval, if the rekey interval is 60 minutes and aggregation interval is 5 minutes, then you have, you roughly you have about 100K or 200K actually. So we are talking, this kind of the order of the magnitude differences between the two. And the point in here is we can use the route reflector both to save messages on the from the ingress PE instead of sending 10,000 messages, send only one message to the route reflector, and use a route reflector mechanism to basically to do aggregation and packing and send a lot fewer messages to the egress PEs. So after this, there is only one more slide, and we are open for questions.
Okay. So I'm really not going to go into this slide much. This is from the draft. This was just a little bit of background information, shows the synchronization and how it's stepped through. It's probably completely illegible up there on the screen, and we'll kind of leave it at that. Last closing thought, all we're going to say is if you've read the draft or heard about it, it was named with a name fairly similar to another protocol common in the security area. That seems to be a linchpin or a touchstone, and it is getting renamed. I spoke to the guy this morning who originally named Ike. He kept saying, I stand by my report. Oh, no, wait, that was Mueller. Sorry. Anyways, he said it was okay. That's it.
All right.
Please take the question from Paul.
All right.
And then I think Ben, Kara,
Sure.
you after. Okay.
Sorry, Paul Otis from the IPsec working group. If you just go back 2 slides. Yeah, this one.
Right.
So the 6 messages is not correct. That's for Ike v1. You will never use that. You'll use Ike v2. So it means that it's at most 2 messages. And if you already set up an Ike SA beforehand, so you only need to create the child SA for the traffic selector part, then it's only 1 message.
To set up the, okay.
In each direction, yeah.
Okay.
Yes. If you're doing phase 1 and phase 2.
Please use mic and yeah.
Sorry. Yes, if you're doing phase 1 and phase 2.
But then in Ike v2, that's still only sending 2 messages and receiving 2 messages.
4 messages. Okay.
Okay, 4 messages rather than.
So now we're at 400 million.
Yeah.
Okay.
Saving of 200 million.
This one's for you.
Okay.
The draft's very well written.
All right. Thank you.
You use route reflectors.
Yes.
In BGP, there is a notion where forwarding is preserved in some cases where control plane goes down. What happens when the control plane goes down? I think the draft can help clarify a few things, as if are you going to preserve the IP keys or the keying parameters? And if so, how long? So that's first comment. It'll help if you comment the second.
On a valid point.
The second thing is, we go beyond 8 AS. So what happens when the keying parameters are leaked beyond AS? Maybe draft should very explicitly explain that while you have route reflectors, your edge spoke nodes can leak this information out. And you can ask security guys out here, what are the security implications of leaking it out?
Clarifying question to yours, Kara, if you'd stay at the mic.
That's for the inter-AS, basically.
No, I'm saying it could get leaked out anywhere within your domain. And so the draft should minimally say, how do you control that? And then use policies to explicitly configure it if you need to leak it out for
What is information, KU, they're getting sent with the associated route targets, RTs?
Yeah.
And so based on the RT, you can control the distribution within your
But
network.
remember, they were routes. This is your
Right.
security information. A little different,
Okay.
right? So you need a text there, probably tightening up.
All right.
Clarifying question on yours.
Okay.
Are you assuming in your discussion the route origin and filtering or BGP-SEC, or are you asking the gentleman to provide elucidation on that as well as what happens when it leaks?
I'm actually asking him very indirectly and politely to add communities to not leak it out by default across the AS and then strip those communities if the policies are needed to explicitly leak it out. Something like that.
That's a good proposal. Thank you.
I mean,
Okay.
It's public key information, but I agree.
Okay.
Ben Kadek, I have a clarifying question, which I think,
Did you introduce yourself? I'm sorry.
Ben Kadek, Security Area Director. So I have a clarifying question, which I
Sure.
think is related to the same confusion that we were having in Sec Dispatch, but I'm going to try it
Okay.
again. Hopefully I'll word it better this time.
Okay.
So if I understand correctly, we've got the 10,000 peers, and then we're going to say we're going to send a single message from each of them up to the controller, and a single message from the controller down to each of them. But that single message down from the controller to each node or peer is supposed to include the nonce and the public key from all 10,000 nodes.
Right.
And how big are those nonce and public keys? I've got 10,000 of them. This single message might end up being megabytes. And am I misunderstanding something here?
No. It basically based on the interval that the aggregation interval that you have. Let's say you send 10K. Okay. That 10K, if the nonce and public key exceeds the single message length, then you're going to be sending multiple messages. But the key in here is you can do a lot of aggregation here. I mean, and we're increasing the size to 64K.
Sure. Yeah, I definitely believe there's lots of aggregation
Yeah.
and other benefits of doing it over the controller and the security. system and
So maybe that can be factored in, and instead of 100K becomes 500K or 600K. But again, this is not absolute. I just wanted to give a feel because we had similar concerns or questions were raised during the Sec Dispatch.
Right.
And I just wanted to, that's why I put this example in there, just to
I appreciate it. I just
get the
want to make
feeling.
sure I'm not
Right.
missing that there's
No,
some
you're not.
optimization going on.
Yeah.
So if I can jump the line.
Sure.
If I understand you right, really the gist of this isn't to get down into the weeds of the exact numbers.
Exactly.
But you're saying that, without a controller in the middle, it scales like n squared, and with a control in the middle, it scales more like n.
Exactly. That's the gist of it. But there was in security dispatch, there were a lot of confusion around this n squared versus n, and that's what I wanted to clarify via the example.
Ben, did you get your question answered?
Yeah, I think so. I mean, I don't know if I would say it scales exactly as n, but it's somewhere between n and squared.
Okay.
Or it's not exactly.
Okay.
Okay.
Thank you.
Stefan from Orange. One general comment people are always talking in this presentation about controller. Controller is supposing to have a kind of intelligence, but route reflectors are maybe the more stupid BGP speaker in the network. So there is no intelligence. So I just want to have a confirmation that you are not breaking anything in the BGP machinery, and what you want is just propagation.
Yeah,
so you are
that's
not using
why-
your controller.
That's why we are, that's very good point. And that's why right from the beginning, I said we got these 4 components. We have the ZTP server, and we have the provisioning server, and then we have the signaling. And all these are part of the big controller, okay, what you call it as a controller. But the signaling part is what we are talking about, RR, with respect to what we are familiar with.
Okay, so whatever the route reflector design that I have using clusters or hierarchical route reflectors, it does not break anything in your IPsec signal.
Yes.
Okay. Cool.
Actually, it helps. Okay.
Okay, and I had exactly the same comment I'd ask you about what happens when the control plane is failing.
Okay.
So do we need to implement LLGR, and what are the side effects?
Basically, in a short answer is if that happens and the control plane fails or isolated, then the rekeying aspects is going to be affected. You won't be able to rekey at the interval that you want.
Pavatus, IPsec. Are we still only on this document, or are we taking things in general?
Anything.
Now?
Yeah.
Yeah, I think that, and in fact, I think we should invite the other authors to, come back up too if we want to open the floor to more, broader discussion. So,
Yeah,
which I think we do.
Some of my questions will apply to the multiple solutions proposed, right?
Please, we're into the discussion
Okay.
part.
Okay. So then I have a list. So the first thing is.
Just Linda, you want to also come, in case.
So my first question is, do we have many more routes than nodes, or how is this?
Oh, that's a good question. Okay.
Because depending on that,
Right.
like if you have many routes and fewer nodes,
Right.
then you could do an IPsec transport mode connection to the node and then run GRE or something and then send all the. So you don't have to have one IPsec as a per route.
Right.
Which might save you a little bit of MTU space as well.
No,
and it would save you a lot of negotiation. If a new packet comes in for a new route, you can just route it. You don't need to set up anything new at that point.
So very good. That's a good question. And that has been, I've described that in some details in my draft, Secure EVPN, saying that we have a different level of hierarchy. Okay, you can have, in some scenarios, you just have a secure tunnel between two peers, okay, at the PE level, I call it, okay, at the box level, okay. However, for some tenants within that box, those are special tenants, and they want to have their own IPsec tunnels, okay, because they don't trust the general one. And then you can go to the next level of the hierarchy, that within that tenant, you can have a host, a CPE host within that tenant that is special and wants to have his own. So it is this, you don't have to have it for every route, but it is flexible.
I understand. So now you gave me an additional problem because with IPsec, you usually have one IKE assay, and then you can have like thousands of child assays for the traffic, but they're still under one domain. So now you might actually have to set up multiple IKE assays between these parties if you think that they're in a different administrative domain based on which tenant they are.
We don't have an IKE assay. Oh, can you use the mic?
Sorry. So in your case, you don't have an IKE assay because
because we're not doing IKE.
Right. But the other two solutions.
Yes, they did, and I wanted to take a pause. Did you, June, are you able to speak?
Yes.
Okay, so Paul, you can also address the same question to June. June, did you get the question that Paul was asking?
Yes, so with my draft, I really don't change anything on the IPsec side because we continue to use, my draft continue to use IPv2 as the way, as signal protocol for the IPsec tunnels. The only thing I do with BGP is to signal the IPsec config. So whatever we do today with IPsec stays the same.
So I understand that part, but the part was more about, are you maybe not better off using an IPsec transport mode tunnel with a GRE encapsulation instead of setting up thousands of IPsec assays?
Yeah, that for some use cases that will work, which means that if you want to, for example, put all your traffic into IPsec somehow, yeah, you could do that. But in some other case, they want selectively to increase for certain traffic. They want to use IPsec for certain other traffic. They do not want to use IPsec. Then you have to or go to different destination for different IPsec tunnel. In that case, you might need multiple IPsec tunnels.
Okay. So if that would be an option, then you would have some way of having to signal this.
Yeah.
Yeah. Okay. So I'll go to my next question. That applies to all of the proposals. So is IPsec optional or mandatory or either? Like, do you block sending the packets, or do you actually?
Setting up the secure tunnel is depends on the traffic. Some tenant traffic wants to go over the secure, and some they don't, and that gets determined by the policy. And also there are cases that I think in the Linda's use cases, you had a case of the public versus private network, and for the public network, for the private network, often you don't use secure tunnel.
Right. So in the case where it is mandatory,
Yes.
then the question becomes, what do you do when things fail, right? Like if the IKE fails to establish, or if you're...
So that depends on the policy. That depends on the policy. A policy might say, okay, I don't trust internet, don't send anything. The other policy says, oh, you know what? I have this
Sure.
private tunnel and use that, and
Sure,
so forth.
but some of these decisions matter for the implementation, because, for instance, if the IPsec is fully optional, you can load the policy into the kernel, but you can't do on-demand triggering of it, because the on-demand trigger would actually then hold the packet, because it would assume it's mandated and it cannot leak the packet in the clear, for instance.
Right.
So I just want to make sure that people realize that. Next item I have is
So that's a good point. I mean, it needs to be captured in the solution draft.
Right. So the next item is MTU. So as soon as you start adding IPsec, of course, there is just the reduced MTU of the data.
Yeah.
I'm not sure if I didn't really see any of the proposals talk about this, or how that affect the original data, or that they think this is not a problem. But I think that needs to be given more thought.
Absolutely. So I'd like to ask, these are good points you're raising. Can you please send the email to the list?
I have my notes on my phone.
Okay.
I'll send it to the list as well. Yeah.
Awesome.
So the next item I wanted to point out is that there's the issue of the RTT. So if you set up an IKE assay already, we call that a childless assay, where you just set up, you do the 2 round trips to authenticate the IKE assay.
So that is not question for us, right?
It's in general, yes. Then you can later on demand, within 1 round trip, get a child assay, and so that saves you from doing a 2 round trip at that point. So that saves you 1 round trip, but it means that you have to set up these IKE assays in advance. So it's a trade-off you might want to think about in your design.
Okay.
The next,
just a quick point. This refers to the first option. His comments. Okay.
Yeah.
John. Okay, John, if you're on the call.
Yeah, so I mean, whatever I provide, we use that. I mean, whatever is available with IKE2, right? We don't really change what IKE2 does.
Right. But again, you might need to, you will need to provision that, whether or not both parties will do that or not.
Yeah, I mean, the config part of that could be signaled by BGP.
Right.
June, this may be good for you to realize that it might be good to have usage or other details, whether that goes to IDR or that might be separated in a separate draft and put out. He's not necessarily specifying BGP TLAVs, but operational stuff that usually goes through BEST. So that might be useful for you.
Okay, thanks.
So next item I wanted to cover is multicast traffic. So currently IKEv2 is in the process of supporting multicast negotiation and group essays, but it's not there yet. IKEv1 used to support it, or actually has IKEv1 still supports it, but nobody should use it. In IKEv2, we are working on it. It's been a slow process, so it would actually be a welcome thing if we have some consumers of this go push the people that are doing this work in the IKE, for IKEv2 to put some momentum behind this and get this done. And I also want to mention there's a session resumption that you can also use to prevent doing an expensive Diffie-Hellman key exchange. So maybe not for you guys, but for the other solutions, if you can, instead of delete the session, you can get a session ticket, resumption ticket, then you can later on much more quickly with less CPU power reestablish a new IKE and or IPsec assay.
Yeah, yes, agree.
And let me just go to my last bits of the part that I already sent to the mailing list, as some of it was already answered in the in the first presentation. Do we have anything? So yeah, just for the first presentation, the examples used were like AES CBC with SHA-384. Please use some more modern things like AES GCM. Let's see. I covered that. There's another issue if a router reboots. So if we have an IPsec tunnel and one of these endpoints fails, I'm not sure what the mechanisms are, whether it's within IPsec that something needs to happen, or whether there's an overlaying BGP security protocol that will take that node out of commission and do something else.
So one of the edge devices fail. So if that edge device fails, the routes to that route reflector withdraws the route to that failed device, and all the other edge devices can turn on their IPsec tunnel to that.
Okay, so basically, you're saying an IPsec failure on a node.
No, I thought you said node failure.
Sorry?
I thought you said node failure. You're talking about the IPsec failure?
Yes, sorry, I'm talking about an IPsec failure. Would that just mean that something else takes that IPsec gateway out of its misery and everything else gets rerouted around that?
Yeah, it becomes a link failure.
Sorry? So, I understand IPsec keep alive is there, but that's a really slow mechanism, and I don't think you want to use that. And let me add as warning. There is a thing called that peer detection or liveness in IKE. Please be aware that the RFC said you should not use these probes for like more than once a minute.
Right.
Some people like to send them multiple times per second, and you get really strange things if you try to do this, including like shooting yourself in the foot because your probe's actually starting to fail.
So IPsec tunnel is one of the tunnel kind. We got the MPLS tunnel, VXLAN tunnel,
Right.
Geneve tunnel, and all that. The question, I would expand it to more general detection of the tunnel failure, and IPsec would be one of it.
Right. I would just assume that IPsec is a service on a failing node, and that node will just get out of rotation. So that, like from an IPsec point of view, you don't need to worry about that.
Okay.
Okay.
It is worth considering whether notes on that might be useful in your draft.
Okay.
Kara, I'm going to ask a favor. Could I ask you to let the next two guys who have signed up as security folks to go first in questioning, and we'll take the rest of the folks as I can in time. In other words, step behind Ben, and then I will be glad. That'll be your turn. Thank you.
Can you a little bit farther? Yeah. No, behind the doors, you know.
Well,
Not happening.
All right. I can, joke with him because he is a good friend of mine.
Yes.
okay. Valery Smyslov, Elvis Plus. Can you go to the slide with a comparison, with example,
Yes.
scalability?
From which slide deck?
This one?
No. On that presentation, with scalability example, that
The one that you did. I think.
enormous number of messages and so on.
Oh,
When you said it.
Which one?
so here, just go forward.
Oh, scroll down. That's fine.
It's last. Oh, yes. First of all, yes, there are some mistakes on the number of messages, as Paul already said. But anyway, I think that this comparison is not completely fair because
why not?
Not that I said that you compare oranges and apples, but it is you go to a bit extreme because in I case. It's a rare case when.
So I just wanted to make sure you don't mistake the apple with the orange. That's why I went to the extreme.
No, but you just go to extreme.
Okay.
And usually, say in I case, usually essay are created on demand, and it is very rare that all 10,000 of people, of peers, will simultaneously create tunnels with every peer it has. So it's extreme. Well, and then another
So
point,
just you have a power outage and then into the city, and
Well,
it takes out the whole nodes, and then the power comes up, and all of
not
them
at one time. It will be
within a window, but it's not going to happen
but anyway,
in 24 hours.
It is unfair for another
Let's
reason.
go on to the second comment.
Just a moment, I have, yes. The other, it's unfair for another reason.
Okay.
This solution, I mean, IKE solution and this kind of security control solution have a slightly different security properties. Because in this case, every node has a single public value. So, for example, if you break this public value, this public key with some, I don't know, quantum computer or something else, it will compromise all the assays it has with every peer. And in IKE case, in IKE, the classical IKE solution, each tunnel is using ephemeral Diffie-Hellman. So if somebody breaks it, it will only compromise a single tunnel, and other 9,999 tunnels will become safe. So it is slightly different security properties. So that's why
yes.
comparison.
Yes, so it is true. It is a shared Diffie-Hellman across all the nodes. Though we do have rekey intervals.
That's why you save the messages for this reason. But you lose a bit security.
So that
You
seems
lose
like something that would very appropriately go in the security consideration section.
Right. I don't want you to think it's not been thought of and not addressed, but it is a limitation, and there's countermeasures.
Ben Kaduk. So I tried to also be thinking, in addition to the specific mechanisms proposed, to try and come up with some general considerations that might apply to all of them. And so, like, in general, you need to consider if you're going to get your configuration through BGP or through a controller, you need to be thinking about how much do you trust that configuration? What other information are you getting through the same mechanism? And if that other information was wrong or corrupted or an attacker controlled it, how would you break for that? And maybe if you're going to be horribly broken already, then you don't necessarily care if your IKE configuration is also broken. And you also always want to make sure to think about what properties do I want to get from IPsec? Like, why am I doing this at all? Do I need to protect the confidentiality of my traffic from some other parties? And if so, which other parties? Do I need to authenticate the peer? And you need to do sort of like a full system analysis to make sure that you're actually getting that property. For example, if you have a system where you do want to authenticate the peer, and instead of relying on a centrally issued or on like some sort of certificate to authenticate the key that you're going to use, you're instead going to say, well, I got this key from a trusted central controller, and I'm just going to trust that central controller to give me the properly authenticated mapping between keys and identifiers. That might change a little bit what your authentication story is, and so you want to think about that. It may not be a problem, but it is something you want to think about. Another thing that's sort of important is if you do want to have the confidentiality protection, it's important to remember that it's confidentiality protection from some entity or some class of entities. And so if it's possible to end up with the wrong configuration, whether that's traffic selectors or your keys or whatnot, it may well be the case that you can end up with a connection that is using IPsec and providing you confidentiality protection from the wrong people, and is in fact connecting to the people that you didn't want to talk to. And so, just because you have a successful IPsec association and you're encrypting your data, you got to make sure you're encrypting it to the right people. And I think in terms of when we're adding multiple ways to distribute configuration information.
Just a quick note, with respect to your last point, it is important because you're gonna try to make the try to make the connectivity over the WAN as secure as possible. But if you don't take care of the cross connect between your end user and the traffic that it is unencrypted, then all your effort is wasted.
Yeah. There's all sorts of ways things can go wrong, so you have to be really careful to get it perfect. I think my last point is just to say that if you do have the multiple mechanisms to get your configuration, as long as everybody agrees to use the normal tie-breaking mechanisms, that's totally fine. To use the tie-breaking mechanisms for if you've got two different things that are trying to claim the same route in terms of what configuration to use. As long as everybody knows what the tie-breaking mechanism, I think that's generally fine. Sorry, I had one more point. There's a lot of these aspects that will be easily controlled using sort of local policy to make sure your traffic selectors actually make sense in the broader scheme, and so you can do sanity checking on some of the configuration you get. I guess it's less so for the controller height than the other two.
Could you say just one more moment about the traffic selectors? Are you addressing that generally then to both presentations, or did you have more for June's presentation and his color selector?
I think that was for both of the first two presentations.
Thank you. And thank you for taking, and Paul, and I didn't catch the middle gentleman's name.
Valerie Smyslov.
Thank you very much for taking the time to think through that and give us such detailed feedback. I know this is being recorded, so I will go back and write myself lots of notes based on it. If you would send any of it to the mail list, we'd also appreciate it.
Yeah, I will try to do that.
Yeah. And just really quickly to address a little bit of the authentication issues, and there's certainly a need for an edge to identify the controller authoritatively and vice versa. Some of that is slightly discussed in my draft, but it's kind of cursory. There's an assumption that has happened. When you look at the architecture, it's going back to starting with ZTP and how does something connect to the network. But I very much agree, it all has to be tied together, that whole authentication chain. Because obviously, fundamentally, none of it matters if I don't know who I'm talking to.
So we were also planning to write an architecture draft that talks about these different pieces and how they're glued together, so that to make sure that the overall picture is clear.
Oh, this will be for you.
Are you sure?
May I? Yes. Thank you.
No, we just.
Go back.
The last presentation for today that was invited on, I warned you, you're off now, so we just have two more idea presentations. You have about 3 or 4 minutes, guys.
Super. I'll be real quick. Kevin Patel, Arcus. 2 more points.
Sure.
Echoing what Stefan said earlier, if you're going to do this using route reflectors, you may want to suggest implementers and operators as to, because there are a lot of messages, not that BGP can't handle, but you will see head of line blocking if you will start mixing up office. So probably, I don't have a good suggestion for you, but probably a separate route reflector or something that doesn't affect routes, actual routes. Okay. Second thing is there was a draft in IDR working group, which actually tracked for labels. If the labels became inactive, they had a way to take the routes out or the next stops out. Because this is an IPsec tunnel, and I think Paul mentioned it's 1 second keep alive, you are more than welcome to reduce it to milliseconds. It's Paul's problem, not mine. But you want to give some suggestion in text to the implementers to say, should the tunnel become inactive, what are the means to detect that tunnel is inactive, and how do you go about doing it? A clear suggestion?
Oh, absolutely. No, that's important.
Yeah, I have a quick one.
Sure.
There's a typo on this on the math actually. Does not change the picture, the big picture, but let's make sure people don't leave the room with this big number. That's the 600 million. That's not. I think the right number should be 100K. There.
For
Well, it was being multiplied by 6 messages, which has.
Yeah, I understand. I understand. 10K, it's n squared, not n cubical. I think that's a typo. N squared, 10K or n squared would be 100K, right? 100K.
10K is 100 million. Is 100 million.
Ah, okay. After all, I thought it's
100 million times a small line.
Okay, it is, yeah.
Stefan from Orange. I wanted to go back to the tunnel on caps and the tunnel types that we are requiring. Because I think we have plenty of different use cases. So we have the simple one, which is IPsec tunnel mode, but then we can use any kind of overlay with IPsec transport mode. So how do we do it? So today we have some of the combinations that are defined in 5566, which may probably disappear. So we need to create something else. So then are we creating a combination of each overlay plus IPsec transport mode, or are we using something more flexible? So telling, for example, that I'm using just VXLAN type plus a TLV telling that I'm doing IPsec transport mode.
Well, the current thinking, that's a valid question and point. The current thinking is the IPsec attribute, the TLV that gets carried in the tunnel and cap is going to specify what kind of the IPsec we have, and then we have this extended community to define what kind of the overlay we have. Is it VXLAN or is it Geneve or whatever? So we've done this kind of thing for the multicast as well, because in multicast we send the PIMC tunnel attribute, and the PIMC tunnel attribute can be PIM or so forth. So with the PIM, question is what is inside the PIM? Is it VXLAN or Geneve or what? So what what we've done is we send the IPMC tunnel attribute to say that this is a PIM tunnel, and then the extended community to say what is the type of the overlay that gets carried inside that tunnel.
Okay.
But that particular piece, you need to think how you might do it with attributes, because you're now into tunnel attributes. Separate point, I needed to, as a chair, ask if we can close the line, because I've got 20 minutes and 20 minutes for the presentation. Did you have a quick one in which?
Okay.
Yeah, I just want to finish with Linda's draft and the tunnel encapsulation types, where you are trying to define the kind of SD1 type, but SD1 is not really an encapsulation. Yeah.
So I didn't get a chance to present how we encode the message into the tunnel in cap. And if I get a chance next time to show details, you'll see that in the tunnel in cap, we need a different tunnel type. So specifically for the overlay, long reach overlay. So I call it SD1. It can be different. Linda.
Okay, and that one, folks, Stefan and Linda would be good on the list as well.
Definitely. So the draft implicitly suggests that relationship between endpoints and distribution point is IBGP. Are there cases where it could be EBGP?
For the if you're connecting the ASs together, because EBGP within the network itself typically is like it used for your underlay. For the overlay, it goes IBGP. So the EBGP that I can think of is for the in case of the inter-AS stuff. Or maybe actually there is
I haven't
one.
thought through, but if there is, probably you want to think about route servers and address it accordingly.
Okay.
Okay, folks, we're going to close the line and go to the next presentation. I want a big thank you for all the presenters and for the IPsec. Thank you, folks.
I want to invite Alvaro to come and say a word or two about the. Alex, before you start, I want to ask Alvaro to come up and say 2 words about Charter, if that's okay, Alvaro. But only 2 words. Please pick them well.
do it. Okay. You guys know, because it's been on the mailing list, that we're looking to recharter IDR. One of the reasons we're looking to recharter IDR is because the charter has a bunch of items in it that have been completed, other items that we're not doing anymore, and it doesn't necessarily reflect everything that we're doing right now. So I know there's been discussion on the list about what the working group wants to do. Talking to the chairs earlier, what we think we want to do, and the discussion is actually going to happen on Friday, so don't even come and ask any questions. What we think we want to do is we want to produce a general charter that talks about what the working group does in general. Who are the other working groups that we coordinate with? BES, GROW, CyberOps, et cetera, all those other working groups. Maybe a little bit of how that happens, maybe call out some specific things to clarify what IDR versus the other working groups are responsible for. If anyone can come up with something that should not be covered by IDR, maybe we want to put it there. But the specific work items, so that we don't run into the same charter with half the items completed and half not, and some that we're not even going to do in another 2 years, and have to recharter again. What we want to do is we want to manage all the work items through the milestones. So what we hope that will do is it will give the chairs a lot more manageability of the working group and a lot more flexibility. If there are things that come up that are more interesting than whatever we've been doing in the last 6 months, we can change some of the milestone orders or whatever with the working group for consensus, and we can move on that a lot quicker. We will hopefully avoid discussions about, well, that is not in the charter, or that is in the charter, or, et cetera, things like that. And again, the other thing we want to avoid is to have to every couple of years go through the painful process of rechartering the working group. But instead, we can just talk in the working group with the input of the other working groups that are close to IDR about what are the important things, or the higher priority things. Everything's important. The higher priority things that we should be working on at any given time. So think about that. And on Friday, I think we're going to have a larger discussion on those items, and hopefully some text on what the charter is going to actually say. Thanks.
Yeah, thanks.
Folks, we will probably run 2 to 3 minutes over because we've run long. I'd like to give each presenter about 10 minutes. Just be warned, we'll just let the next presenter go.
Okay. Hello, I'm Marcia from Cisco. Today I'm going to present the updates to the draft BGP BFD street mode. Since last IETF, we have a new co-author. Jeff has joined us from Juniper.
Hold the mic in front.
Okay. All right. The draft was presented at IETF 104 in Prague. And since then, main updates to this document are BGP finite state machine with the BFD street mode. We also proposed the BFD hold timer. Both manageability and security consideration sections are revised also. A quick recap of the draft. The BGP BFD capability, the BGP BFD street mode is a solution proposed to address the BGP and the BFD interaction issues. This solution defines BGP BFD capability and enables the BFD capability negotiation. Operations are a BGP speaker which supports capabilities advertisement and has BFD street mode enabled must include the BGP BFD capability with the S-bit set. In the BGP capabilities, it advertises. Okay. A BGP speaker which supports BFD capability and examines the BFD capability received from its peer. Okay. If both the local and the remote BGP speakers have BFD street mode enabled, then BGP session will be established after BFD session is up. If either BGP peer has not advertised the BFD's capability with street mode enabled, then BFD session state will not be required for the BGP session establishment. Okay. Please note that this does not preclude usage of BFD after the BGP session establishment. The new updates, BGP final state machine with BFD street mode. If both the local and the remote BGP speakers have BFD street mode enabled, the BGP final state machine does not transition to established state from open send or open confirm state until the BFD session is up. Okay. In this state, no keep alive messages are sent. Okay. The keep alive timer is not set. If BFD session does not transition to up state and negotiate hold on timer has non-zero value, then BGP final state machine will close session after BGP hold timer expires. In the case the negotiated hold on time value is 0, then a BFD hold timer with a default value of 30 seconds is proposed. So after the BFD hold on timer expires, BGP final state machine will close the session. Okay. If BFD session is in admin down state, BGP final state machine will proceed normally without input from BFD. Okay. If BFD is disabled or deconfigured from a BGP peer and BGP session is held in the open send or open confirm state, then BGP will close session and start a new TCP connection. Updates to manageability and security consideration. A BGP notification message subcode indicating BFD hold on time expiration may be required for network management. This will be discussed in next revision of the document. The security consideration of BFD becomes considerations for BGP when it's used. The use of BFD authentication mechanism defined in the IFC 580 is recommended when used to protect the BGP. Review comments are real-com.
And folks, we're running that long that I'm going to give her a bit of time or ask us to go to the list. And I think we'll slip in Alexander. So I'm sorry to trim your comments if you will catch her afterwards. Alexander, why don't you go for about, I've got enough time to.
Sorry, go ahead.
Why don't you give the brief 2 or 3 points you need before grow, or do you need the full 10 minutes?
Let's go.
Go, you got it, then. Thank you very much.
It's 10 minutes for small values of 10.
Okay, just a minute. I gotta get
Hello. Hello, everybody. My name is Alexander Azimov. I work for Yandex, and this will be a very quick update for BGP roles draft. So, the core of the original design is BGP roles. BGP roles is a proposed new configuration parameter that is negotiated in open BGP in open messages. So there are 5 specified roles: customer, provider, peer, route server, and route server client. So the draft was already here for at least 3 years. Originally, it was a transit attribute to detect and prevent networks from leaking. After that, it was split into two, IOTC for prevention, EOTC for detection. Then it was merged with another attribute from another draft. Then ISP emerged, and it changed the field slightly because we need a solution faster than we were thinking previously, and that's why RLP attribute was transformed into do community. And IOTC was nearly ready for working group last call. We had implementations, and now happens major redesign. And I'm going to go through and explain why it's happening and why it's happening now. So please take a look at these rules. I will spend more time on this slide than on any other slide because it is important. First rule is a quote from leak prevention draft. It says, if a route is received from provider, route server, or peer, it must not be sent to another provider or peer. In other words, it must be sent only to downstreams, only to customers. Second rule, if a route is sent to customer, peer, or a REST client, it also must follow only down rule. So these rules are nearly the same, but represent the picture from different sides of BGP session. One rule for receiver and one rule for the sender. But in general, they are just the same. So we're getting OTC back. We're getting a transit attribute that is capable for both prevent networks from leaking and detect anomalies. So, and also it is improved OTC attribute. It has a different design from the original one. It says that on ingress policy, you must set this attribute if it is not set, and if we are receiving a prefix from route server, provider, or peer. On the ingress policy, you are saying that if OTC is not set, you are setting it when sending it to customers and peers. So the picture how it's working. On the left-hand side is provider. On the right-hand side is customer. No matter who is setting OTC, the value will be the same. So we are getting a tool that has that negotiated its configuration. Plus, we also have a double-checked configuration of OTC attribute. With this attribute, we have a very simple rules for a root leak detection and prevention. So I will just drop this slide and go through the example. Here, IS1 is sending prefix to IS2, to its customer. Again, no matter who is setting OTC, it might be set by IS1 on egress, or by IS2 on ingress. The value will be the same. The value will be AS1. And on the other side of Atom System 2, it must be checked that OTC exists. So if it is checked on egress, where we have leak prevention. If it is checked on ingress, we have leak detection. So we have roles that are negotiated on both sides. We have marking that is done on both sides. And we have leak detection that also is done on both sides. So the interesting question is what we should do with route leaks. And it seems that the only policy that can be applicable for route leak mitigation, you must drop them. But in certain situations, you may want to pass them by, for example, just to learn the signal before applying this must drop policy. So I will get to this question in more detail after the coffee break during growth session.
And Joe, will you tell us when the growth session is?
Yeah, it's here.
Next session, this room.
Yeah.
So stay here and enjoy the next. Thank you.
And the last question that must be highlighted: for years, during discussion related to root leak detection question, we had an argument. Which one is better? Should we go with community or should we go with attribute? Attribute is more native. It's a more reliable signal. It's memory efficient. It's not overloaded with different functions. But community is easy to deploy. We can, in selected networks, we can deploy it tomorrow. In Yandex, we can deploy it tomorrow. So instead of arguing which one is better, we decided to do both. So there will be an OTC, a proper attribute that will be used for leak prevention and detection. And there will be also a community that will model OTC behavior just for same purpose. The difference is that OTC will be available in a couple of years. Community can become available in a month. So there's some summary on the current status. So we transformed IOTC to a transit OTC. We have marking on both sides. We have configuration check on both sides. We have filtering on both sides. Roles can provide automation for solution for both community and attribute. So thank you for listening. I don't think we have a lot of time for questions, but you can
Come to grow and ask.
Yes.
The other thing is, if it's an attribute, it has, send it back to IDR for that. Okay.
Yeah. So if we are changing the attribute style, we need to ask for another allocation. Am I right?
Yep.
Okay. Good.
Thanks, everybody. See you Friday.
That went.
Yeah, please.
And say,
just say.